And yeah, pray for the wrestlers. I'm going tonight. How is St. Mark's? Are they good in wrestling? They're not that good? Do you know who, Jake, do you know who you're wrestling? Do you know the guy? Have you wrestled him before? Oh, really? How is he? He's pretty good. All right, good. All right. Is there any other wrestlers in here? Nico. All right. Okay, let's turn our attention back to this. So let's take a look. We're going to do a thing called the Orthocenter. But before we do the Orthocenter, remember yesterday before we did the Circumcenter, we talked about perpendicular bisector. Agreed? All right, so now we're going to talk about something else, and then we'll do the Orthocenter. All right, so let's talk about something first on this little program right here. And then we're going to switch over to GeoGebra, and we're going to show you how to find the Orthocenter and what that does and all that kind of stuff. It really doesn't do much, okay? It's just, I'll just tell you right now, the lines just intersect each other, and that's it, all right? But it is something that we need to know.
Middle school girls basketball, your dismissal is now. Thank you.
Okay, so let's do this. We're going to start off kind of like what we did yesterday. We're going to start off with a line segment. Actually, to tell you the truth, it doesn't even have to be a line segment. I'm not even going to make it a line segment. It could be a line. It could be a segment. It doesn't matter. Okay, it could be one or the other. So before we do the geometry part, has anybody flown in an airplane, like a commercial airplane, and the pilot talks to you and stuff like that? Only about 3 of you? You ever been on an airplane? Not actually driven the airplane, but been in an airplane. Okay. So you get up there.
All right, that's enough.
So you get up in an airplane, and the pilot gets on there, welcome, blah, 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 and all this kind of stuff. And he tells you what the altitude is. Usually when you get to your highest altitude, he'll say, oh, we're cruising at an altitude of 30,000 feet or something like that, okay? You ever hear that? All right, that's what he does. So when they talk about the altitude, all right, so here's my plane. I'm the world's worst artist. I'll admit it. Boom, boom. Yeah, that's what I am, sure. So that looks like an airplane, kind of, doesn't it? All right, and so you're flying along. What is he talking about as far as the altitude? Is he talking how high you are? Right. So is it like from here to here? Nathan, go ahead. Tell me. Okay, give me a good math word, though, a geometry word. Instead of straight down, what geometry word would you use? Perpendicular. Very good. Okay. So instead of just saying straight down, which would be okay. I mean, I understand what you're talking about when you say it, but we're in geometry class, so it's perpendicular. It's the perpendicular distance, okay? So what does that mean? That means that distance right there, that's your altitude, isn't it? Okay, it has to be what to the ground then? Perpendicular, which means it makes a right angle, 90-degree angle. Everybody got that? So when we talk about the altitude, let's write that down. Altitude. The altitude is the distance. Let's say it this way. It's the perpendicular distance. Everybody got that? So the altitude is the perpendicular distance. So if it's from one point to a line, it's the perpendicular distance. Because if I just said the distance and I didn't specify perpendicular, I mean, that distance could have been from here to here. Is that the same distance? Is that perpendicular one? No. Is that the same distance? Is that the same distance? No. So we have to agree on something, right? We got to agree like what the measurement is, and it's always perpendicular, all right? So when we talk about the distance or the altitude, that's the perpendicular distance. Everybody got that? That's really important, okay? So just the definition of altitude is the perpendicular distance to that thing right there, all right? Good enough. So guess what? We're going to use altitude when we find the orthocenter, all right? So let's switch over to, and I got to switch this over. I got to unclick that. There we go. And hopefully this will work this time. All right. So what I'm going to do is just draw lines. I tell you what, let's draw a polygon, okay? Or a triangle. So there's a, oh, why did it do that? That's weird. Oh, I know why. Let's I think it's because I'm using this pen. Let's not use the pen. Let's go from here. There we go. That's better. It's because for some reason when I use that pen, that graphics pen thing on this, it doesn't work as well. I don't know why. So there we go. We got a triangle. All right. I can move it around. I can change the shape of it, all that good stuff. All right. Well, what do you think, now that you saw what we did yesterday to find the circumcenter, what do you think we're going to do today to find the thing called the orthocenter? We're going to take each side and find the what?
Distance. Like,
We're going to find the altitude. Right. Okay. So what I'm going to do, I should say this though. From a point. Remember on the thing we just did, the altitude is from a point to the line. So this thing right here. So AB, everybody see that? I want to find, and I'm going to change this. This kind of looks, how about like that? I don't want to, it still kind of looks too much like a right. There we go. Yeah, too much. I don't want it to be, I just want it to be a regular acute triangle, okay? So what I'm going to do is I'm going to find the altitude. So let's go from A. So I want to go from A to the side that's opposite A, but I don't want to just go anywhere from A to this side. I want to go from A, and then how am I going to hit this side BC right here? I want to hit it at a, what kind of an angle? A 90-degree angle, right? Okay, so I should have practiced this before, but I think this will work. Okay, perpendicular line. So if I click perpendicular line, I think if I click from here to, and I click on this line, oh, there it goes. Yeah, it did. So that made a perpendicular line. Okay, so what is that line right there? That's an what? Yeah, it's perpendicular, but what's the word? Come on. We just talked about it. What is it when I go from a point perpendicular to another side? It's an altitude. It's the altitude, okay? So this thing right here is an altitude. Everybody got it? Let's do this. Let's put a point in there just so we can name it so I don't have to just like point at it, all right? So AD is a what? Is an altitude. Everybody got it? All right, so now we're going to do the same thing from point B to side AC. So I click on this thing that says perpendicular line. I click on B, and then I click on this line right here. What's it going to do? It's going to make a perpendicular line from point B to that line AC. Boom, right there. Okay, you got me on that? Okay, and let's just put a point right there, and that's point E. We good? Let's do it one more time. Perpendicular line. Now, where am I going from and to? I'm going from C to AB. That's right. So I go from C, so I click on C, and I click on this line segment AB. Boom. And look what happens. All three of those, give me a good geometry word we talked about yesterday. Yeah, they intersect. Give me a better word. Three lines, two or more lines that intersect at the same point are called what kind of line? Starts with a C. Concurrent. Very good. They're concurrent lines, okay? They do intersect. That's absolutely true. But they're called concurrent lines. Let's put a point right here where they intersect each other. Right there. And I believe if I right-click on it, no. If I double-click on it, yeah, and I click on this, this is what I want to do. I want to call this. This is the orthocenter. So we just found the orthocenter. There we go. See that? That right there, that point is the orthocenter. I could move this around, right? Sometimes the orthocenter could be outside the triangle. When do you think the orthocenter is on the outside of the triangle? When it's an obtuse triangle, okay? What if it's right on it? Then it's a right triangle. But notice where the orthocenter is. It's right at the right angle, isn't it? You see that if it's a right triangle? But if it's an acute triangle, where's the orthocenter? It's inside it, okay? All right? Now, remember yesterday we talked about the distance, and I talked about it like 4 or 5 times in here already today, that the distance from the circumcenter, remember the circumcenter? The distance from the circumcenter to the vertices was the same. Is that necessarily going to be true here? No, because look, from here to here is definitely not the same distance as it is from here to here or from here to here. There's really nothing significant about the orthocenter. The only thing significant about the Orthocenter is that they're concurrent, that they all meet at one point. That's it. Okay, nothing special about it. Now we're going to do, again, I can't remember, 2 or 3 more. I think there's 5 altogether. We're going to do 2 or 3 more that there is a significance, okay, but with that particular point where they all intersect. But on the Orthocenter, it's kind of a blah, kind of a boring one. But that's it. But but you're going to need to know how we found the Orthocenter. How did we find the Orthocenter? We found the what of the 3 sides? We found the altitude. Okay, now they are perpendicular, it's true, but we found the altitude. So let's review. Circumcenter. How did we find the circumcenter? Perpendicular bisectors of all 3 sides. Okay, everybody got it? What's significant about the circumcenter, though? The significance is, it's what? The circumcenter. Like, what's true about it? We said it like 4 times already today. It's equidistant from the vertices. Okay, that's circumcenter. That's not today's. That was yesterday's. The orthocenter, how do we find the orthocenter? Find the altitude of all 3 vertices, okay? Find the altitude. Is there anything significant about the orthocenter? No. It's kind of boring. Nothing, no big deal about it, all right? There's nothing significant. The only thing I guess significant is if it's an acute triangle, it's inside. If it's an obtuse triangle like this one, it's outside. And then it could be right on it. It's equidistant from the 3 vertices, okay? All right, we good with that? Okay. I don't think I did this yesterday. Let me do this for you today. Maybe I did. Did I show you the right angles and stuff like that? No, I think I did that today when I taught yesterday's lesson because I messed it up. Let me show you this real quick. This really doesn't have to do with anything, but it's just kind of cool with this program. So let's say I wanted to find that angle B right there, find out exactly what it is. Okay, this program will tell you exactly what it is. So if I click on angle, then come over here, hit one of the sides of the angle, hit the other side of the angle, it'll tell you exactly what that angle is. I'll put it up here.
Senior class is excited to announce we will be having our annual Saltsurf volleyball tournament on March 10th in the Student Center. The Saltsurf volleyball tournament is where the boys are the volleyball players and the girls are the coaches. This year we will be having a faculty team, a middle school team, and a team for each high school grade level. If you would like to participate as a coach or a player, you must order a t-shirt. The forms will be given out tomorrow, and they are due by February 17th. The coaches for each grade level have already been chosen, and the coaches will have meetings with each grade level to pick the players. Thank you.
What's that? I'm your coach? Am I? I used to coach boys volleyball, actually. Yeah. For like 3 years, I coached boys volleyball. And I coached girls volleyball for 5 years back in the day. Is that what it is? Yeah. All the geometry. Hit it at an altitude. All right. So watch this. That's kind of cool, right? It tells you what the angles are. So watch this. I could actually put it right there. There it is. There's exactly 90 degrees. Where does the orthocenter hit? Right at the 90-degree angle. All right? And they do. If you add them all up, they'll add up to 180. All right? And they should always. That's a acute triangle, and you can tell by the angles. And this would be a what? An obtuse triangle, right? Do you see that 180? See, that's 102. It's bigger than 90. So that's an obtuse triangle. So that's kind of cool that this program does that. I just figured I'd show it to you. All right. Yes, ma'am. Yes. All right. So let's go back to my other program here. To Illustrator is the name of this program. And I think that's all I'm teaching today. Wednesday. Yeah. All right. So you have the homework from yesterday that I assigned. All right. And then here's the new homework. So, yeah. All right, so it's yeah. Whoops. I hate when that happens. So it's page 211. It's 18 to 28. 18 to 28. So that's today. Listen. Shh, shh, shh. No, we're not finished because we got the rest of the time. You got about 16, 17 minutes to work on the homework. This is your homework. Now, you also had a homework from yesterday, and we're going to go over both of these. Yeah, we'll go over both of these tomorrow, okay? So, section 5.1a. So, there's going to be two separate assignments. So, it's going to be 10 points altogether, okay? 5 and 5. And this one, you should have already done. It's 209 to 210. So, it's pages 209 to 210. I want them separate. I want these separate. Everybody hear me? I want these separate. 1 through 7. So that's your homework. Okay. So here's your two homeworks. There's 5.1a. There's 5.1b. And I want them separate. Make sure you label them correctly, please.